Hey guys, what's up everyone? How are you people doing? Hoping that all of you guys are doing good and welcome to today's session. Welcome back people. This is going to be session number 2 of mechanics for ICSE 10th class 10. And before we get started, let me introduce myself. My name is Anoop and a very warm welcome to all of you guys out there. Hoping that all of you guys are doing good and taking very good care of yourself in these dire times. Once again, welcome. So people, today this is what we're going to talk about. We'll be talking about single fixed pulley as well as and single movable pulley as well, and this is lecture number 2, which means that we've already completed one session. I want all of you guys to go through the recordings of that so you understand, watch the video so that you understand what we have done in the last session, so that you can connect both the dots and understand what we're going to do in today's session, because that is very essential to understand what we're going to do in today's session. Alright guys, so that's it. As always, we'll start off this session also with a very interesting quote, and the quote for today is this, guys: you can always do more than you think you can. And that is very true, because sometimes we feel like we have done our best, but then no, there's always chance for improvement. There's always something that you can do better, and there's always something that you can contribute more to whatever you're doing. It's just that we have to, imagine that it's possible, and then it will be possible. So I hope that all of you guys will live your life with this agenda in mind. With that said, let us get started with today's session. So like I told you in the last session, we talked about the mechanical advantage, velocity ratio, as well as the efficiency of the machine. We understood how to calculate all of these and what exactly are those. So today we'll be understanding about the single fixed pulley as well as the single movable pulley. We'll find out what is the mechanical advantage in all of these, in both of these, and also we'll understand about the velocity ratio of both of these, as well as the efficiency of both of these machines. All right, so that's it. Let us get started. Now, before that, we also did I gave you a homework question in the last session, and first of all, hats off guys, well done. So this was the question: when a machine pressed by effort move down a distance of 100 centimeter while the load is raised through 25 centimeters at the same time, find the velocity ratio. So suppose if I find out the velocity ratio, they've given you the if you remember the formula, I told you that velocity ratio is equal to basically the distance moved by the effort divided by the distance moved by the load, or the displacement of the effort divided by the displacement of the load. That is what it is. So I'm just going to represent it as distance moved by effort divided by distance moved by the load. So that is a formula, guys. Now it's very simple. Just substitute the value by the load. So you just have to substitute the values and you would get the answer. The effort distance is basically 100 centimeter, because when a machine pressed by the effort moves down a distance of 100 centimeters, so that will be the distance of the effort divided by the distance of the load is 25 centimeters. So divided by 25, as simple as that. You'll get the answer as 4. As simple as that, guys. So the answer to this question is very straightforward. It's nothing but 4. The velocity ratio is nothing but 4. With that said, guys, these are some of the heroes who managed to give the answer in the comment section below really fast. We have Suhas, Sahana, Dharmender, Nityagya once again, Angelina, Abhya, and also Aditya. Congratulations, guys. Superbly well done. I am proud to see such amazing results. Such amazing response from you guys. I hope to see more such response from you people. With that said, let us now understand about the pulley. First of all, guys, pulley is a very simple system. You guys already know about it. Pulley is a simple system. It's not, it's something that is known for its convenience and direction, not so much known for its, as a force multiplier or anything else for that matter. It is known for its convenient direction, because it's easy to pull something down with gravity than to go against gravity. So your effort is actually reduced, or not reduced per se, but it's it's in the convenient direction. It's like, for example, it's easy to carry 100 kg or maybe 30 kg in your backpack than to carry it like this. So it's easy to carry your books. All your books might together weigh like 30-40 kg, but it's easy to carry in your backpack, because it's your basically work done against gravity is 0, so you feel like there's not much effort done. But then if the same 30-40 kg, if I ask you to carry it like this for the entire day, you would not be able to do it. So yes, just like that, here also it's more about the convenience and direction. That's why we prefer pulley over other simple systems in certain cases to lift up heavy loads. Now, thing about a pulley is, guys, this is one of the most important part of a pulley. Probably seen this, Maybe not these days because we all live in cities and we don't have much of well and stuff. But if you ever visit your, if you ever go by your native places and all that, if you go to your village, you can probably see, like, in villages and all, people still use well. And this is one of the most common sites that you can see over there. So basically what it is nothing but a wheel and an axle for pulley. So this is the axle, the center part, which, which basically around which the wheel rotates. This is the wheel, and the wheel, if you look at it, it's actually grooved. So what do I mean by grooved is that it basically has a small kind of hole in between. It's like, in your tires and all that, you have small grooves. In your shoes also, in your running shoes and all, you have those grooves, which gives you better friction, right? That is the whole point of having a groove. So what is a groove? Is nothing but that hole, that different patterns that you see, different shoes that have different patterns, those are called as grooves. So here also you have the groove. So what is the function of the groove? Is basically you put the you put your rope around it. So the rope basically goes between the like in the groove, so it stays inside the groove so that it does not easily slip off when you're applying a force left or right. So that is the whole point of it. With that said, guys, this is the parts of a pulley. Now the thing about pulley is that a pulley is always fixed. So what happens is this part is always fixed to a rigid surface. It's like maybe a cement slab or maybe a wooden plank, whatever it is. It's fixed to a certain point, and then the pulley is hanging above that particular point. So you have this is the fixed point. This entire thing is called, this is the frame. So this entire thing is called as a frame. Then you have the disc. So that disc can also be called as the rim. So you can call it as a rim or you can call it as a disc. It does not really matter. This is the grooved part of the rim. I told you the whole part where you can put in the rope, and these are the nails, and you have the axle around which the wheel or the rim rotates. Now if you look from the top, this is the side view of it. So if you look from the top, this is what it would look like. Pretty much the exact same thing, just that you can see the entire structure of the frame going about it, and also you can see the clear grooves over here, which is the dugout part of that particular rim. As simple as that. Now that you've understood this, guys, let's talk about the types of pulleys. Now you have different types of it. Let's talk about single fixed pulley and a single movable pulley. We're going to talk about what is the mechanical advantage of both of these. We'll understand about the velocity ratio of both of these. How do we find the velocity ratio of both of these, and also the efficiency of both of these pulleys as well. So we'll talk about all of these things right now. So yes, guys, this is what a single fixed pulley looks like. A very simple structure, especially when you near the well. Like I told you, if there's a well, generally you see it over there. Now the reason why we use it over there is because it's harder for you to bend down and pick up the bucket, and it's much more harder for you to do that, rather than you could just pull it down, and whatever force you put on the rope, the higher or the more, that same amount of force would be applying on the load as well. So you can easily lift up the bucket no matter how heavy it is. It is easier for you to lift it up when you're pulling it like this, rather than bending it down and taking it. So it makes your life a little easier, because again, the convenience and direction is what we're looking over here. Now, so this is where the load of the load in the pulley is kept. One side you have the load, and this is the load, and this would be the effort. That is where you put in the effort. So this is how your pulley would work. So basically, you see this, it starts rotating, the axle rotates, or the rim rotates about the axis and axle, and then you can lift it up. So you put the effort over here, and the load gets lifted up to that particular distance. Now, if you look at the axis of rotation, it is not moving. The axis of rotation is fixed. It's not, the axis is not coming, it's not going up, or it's not going down, it's not going to the left, not going to the right. It is in the exact same place, and basically the axle or the wheel rotates about that particular axis. So it's fixed. The axis of rotation over here is fixed. It's not going up and down or left and right. It's fixed, because you see this, it is the entire pulley itself is hanging to a rigid structure, so it's fixed at a particular point. Now the thing is this, guys, this is what you generally do in a pulley. So you have the load, you put in the effort on one side, or you pull the rope from one side, and the load gets lifted up to whatever height you want. Now when you're applying when you have a load on one side of the pulley, what happens is that it is applying a force, right? There's a force. Obviously the weight of the load is acting downwards, because again, weight is what the force applied on the body because of gravity. So that is what it is. So if there's a force acting in the downward direction, what happens is that the rope or that string gets pulled. Obviously it's getting pulled right now because this is, this is going downwards, but the rope doesn't want to go with it, so it's getting pulled. Now here is the thing, guys. When it is getting pulled, there is some force on the string called as the tension force. All right, so the tension force is generally represented as capital T. So what is the tension force? The force applied, or the force acting on the string when the string is being pulled. So you see this here, it is getting pulled by the load, and so there's a tension force which is equal in magnitude and opposite in direction to the load. So whatever is the load, it'll be equal in magnitude and opposite in the direction of the load. So here the load is going this way, so tension is the opposite direction. Here also, when you're applying a effort over here, also you're applying some force. So obviously when you're pulling it down, there's tension on the other side of the string as well. So what happens, there's a tension over here as well, which again would be in the opposite direction because you're putting the effort in the downward direction. So tension is in the upward direction. Again, equal in magnitude but opposite in direction. Now here's the thing, guys. In a single fixed pulley, whatever is the effort, that would be equal to the load. What do I mean by this? Let's take an example. Let's say that the load is, let's say, around 50 Newton. All right, the load is around 50 Newton. The weight is around 50 Newton. You can say that the weight is 50 Newton. Now, this means that only if I apply a force of at least 50 Newton over here, only then I'll be able to lift it up. If the force is less than 50 Newton, then I would not be able to move the load at all. So I need at least 50 Newton force to actually pull it up. So what does that mean is that, so if you have a heavy object, it's not possible. You can't ask a little kid to pull it up, because whatever force he applies would definitely be lesser than he will not be able to apply so much force as you could. So that's what I'm going to say. It's not a force multiplier, so that if you just you pull it with your pinky finger and then it comes down, it does not work like that. But like I told you here in this case, so whatever effort you put in, the load would also be the same. So whatever is the load, the effort would also be the same. So if it's 50 Newton force, then you have to apply 50 Newton force as well to lift up the load as well. So in this case, if you have to find out what is the mechanical advantage is what? Load by the effort. Now the load and effort is equal. So what happens? It'll be equal to 1. It'll get cancelled out. So it'll be equal to 1. So mechanical advantage in a single fixed pulley would be equal to 1. What about the velocity ratio then? What is the formula for velocity ratio? The distance moved by the effort divided by the distance moved by the load. Now in this case, that will also be equal, because how much ever I pull, how much ever distance I pull the rope, how much ever effort I pull, and how much ever displacement happens, the same amount or the same number of displacement or the same magnitude of displacement would happen to the load as well. So it's going to be the same. How much ever I pull over here, it'll be the same I'll achieve the same distance over here as well. So the mechanical advantage as well as the velocity ratio in a single fixed pulley would be equal to 1. So whatever force I move downwards, the load would also move the same distance upwards. As simple as that. Now the thing is this, guys. Now we are talking about an ideal single fixed pulley system. I'm not talking about the real, in the real world, that is not the case, because obviously there'll be a lot of loss. Whatever effort you put in, some amount of it has to, you have to overcome the friction, and you also have the weight of the rope as well. So there is extra effort that you have to put in. So yes, but then here in this situation, or in our ICSE 10th, we are not going to consider any of that. We're just going to consider that the pulley is completely frictionless. And more importantly, we're going to consider that the rope is also, you can say that it's weightless. In other words, it's massless. So we're going to consider it as a negligible mass, not massless per se, but negligible mass. It can be ignored, very small value. And friction, on the other hand, is considered to be 0, because obviously there'll be a lot of loss, other loss also happening. But we're not going to consider all of that, because if we consider that makes things a little bit more complicated. So let's avoid all of that. Now we'll talk about the efficiency, guys. Efficiency is what? The formula of efficiency, if you guys remember it, efficiency is equal to what? The mechanical advantage divided by the velocity ratio. Very simple. So if the mechanical advantage is 1, velocity ratio is 1, so it's also equal to 1, which means that it'll be what? 100%. So the efficiency in a single fixed pulley system would be 100%. So whatever effort you put in, that much amount of displacement of the load would also happen. So whatever is the distance that you displace, whatever the displacement of the effort is, the displacement of the load would also be the exact same. No difference whatsoever. Again, in a ideal fixed pulley system. All right, remember that, guys. Don't just put it like that. It is in an ideal case, not in the real world, because in real world there are a lot of losses happening. All right, so that is about fixed, single fixed pulley. Now to talk about a single movable pulley. How does it work? What does it look like? So basically, guys, a single movable pulley is something that you see especially in construction sites. So these things that you see, these are basically single movable pulleys. So if you look at this, unlike the fixed pulley system that we just saw right now, here the pulley over here can be moved. It can move up and down. So it's not fixed at a certain point. So it can move up and down. So that is why it's called as single movable pulley. So you see this one end of it is fixed, whereas this is the side where you're going to put the effort, and the load is actually on the bottom. So our load is over here, the effort is, you're pulling it upwards this time. So in a fixed pulley, you are pushing it downwards, you're pulling it downwards. Here you're pulling it upwards. So the effort is this direction, and you have the load which will be in the will be acting downwards, and then you have one side of it fixed to a rigid surface. So that's how the single movable pulley works. Now here, like I told you already, the axis of rotation in this case is actually moving, because you see this, it is going up and down. It is not fixed at a certain point. The axis is actually moving. The axis of rotation is actually moving up and down, and because of that, it's called as a movable pulley, because obviously it's not rotating at a fixed point. It's moving up and down as well. So the axis of rotation is clearly movable in this particular scenario. So you see this, the effort is again in the upward direction, the load is in the downward direction, and the tension would obviously be in the upward direction in both the strings over here. So to talk about it, basically this is what it look like. This is what it will look like. So you have the tension both going in the opposite direction again, and you have the load which is acting downwards towards gravity, and then you have the effort which is in the opposite direction or in the upward direction. Now in this case, guys, in a single movable pulley, whatever is the load, the tension on the string would be divided into two, because you see this, it's like whatever is the load. So here what happens is the tension is equally divided. So tension is equally taken up by both the sides of the string, not just one single string. Both the sides of the string are having the same amount of tension. So basically what I'm trying to say is that load would be equal to T plus T, the addition or the sum of both the tensions on the rope. And if you talk about the effort in this case, it'll be a little different. Why so? Is because, see, effort is what, guys? Effort in this particular scenario would be basically in this situation, if you have to talk about the effort is equal to the tension of the rope. So whatever whatever effort you put in, it'll be the same. It'll be in in this case, it'll be in the same direction as the effort itself. The tension, if you look at it, it'll be in the same direction as itself. So whatever is the effort on the string, or on the effort side, the tension would also be the same. Now, tension, if you look at this, load is equal to T plus T. So what did I get? Load is equal to 2T. T plus T is 2T. Now, what is T? T is equal to L by 2. Very simple. Now I saw that effort is equal to T. So can I replace, in place of T, can I replace this equation? Absolutely. So in place of E, can I write it as L by 2? Now, what I'm trying to say is this, guys. In a single movable pulley, the effort is half of that of the load. So if in case the load is, let's say, 100 Newton, the effort would be 100 divided by 2, which is 50 Newton. So your effort is reduced in this case. So basically what I'm trying to say is that this would act as a force multiplier. Why so? If you calculate the mechanical advantage, what is mechanical advantage? It's nothing but the load by effort. In this case, the load is basically L itself. I'll just keep it as L, and effort is L by 2. So you just saw that it is nothing but L by 2. So if you substitute the values, so what if you just take, rearrange the equation, you'll get as 2 L by L. L gets cancelled, so you'll get it as 2. Now I told you in the last session that if the mechanical advantage is greater than 1, then that would be a force multiplier. So here, in a single movable pulley, mathematically, we have proven that it's actually a force multiplier, not just for convenience in direction. Here, the convenience in direction is thrown out of the window, but it is more for the, it more acts like a force multiplier. That's why it's used in big construction to lift up very heavy loads, because it acts as a load or effort multiplier. So that is the reason for this. So this is what it is, guys. Now to talk about the velocity ratio. If you want to find out the velocity ratio, what is the formula for velocity ratio? The distance moved by the effort divided by the distance moved by the load. But here's the thing, guys. In this situation, the distance moved by the load would actually be d by 2. Why d by 2? You may ask. Here's the thing, guys. When you put some effort over here, what happens? The pulley also comes up, the load also comes up. So load also gets displaced to a certain distance, and the rope also gets displaced to a certain distance because the rope is also getting pulled up. So the rope is also getting displaced. The load is also getting displaced. So because of this, the distance or the displacement of the load will be d by 2. Whatever is the distance, the displacement of the effort, it will be half of that. Or basically you can say that because the string is also moving up and the load is also moving up, it will get halved. So dl, that is the distance moved by the load, is equal to the distance divided by 2, or the distance of the effort divided by 2. So de is equal to d. So whatever is the effort that you put in, the distance will be the same, but in terms of effort or in terms of the load, it'll be d by 2. So here, if you calculate the velocity ratio, that is basically de by dl, you will get it as 2 again. So here, guys, the velocity ratio would also be 2, and the mechanical advantage is also 2. So now to find out the efficiency, what would be the formula of efficiency? Mechanical advantage divided by the velocity ratio. So what you'll get, 2 by 2, which is nothing but 1 again, which again is 100% efficiency. As simple as that. So in both the cases, the efficiency is 100%. Again, I'm repeating it one more time, in an ideal case, not in the real situation, because obviously again there's a lot of friction, there's the weight of the rope, a lot of things have to be considered, but in an ideal case the efficiency would be 100%. Alright guys, with that said, now the question is this: how do I change the effort using a movable pulley? What is the thing that I can do to change the effort that I put in a movable pulley? So what you can do is basically, guys, you can connect a movable pulley and a fixed pulley one after the other. This way you would be able to change the effort, because the effort would be the same as the movable pulley, because over there the effort is half of it, so it is a force multiplier, so the effort would be the same. But more importantly, the direction of the effort applied, or the direction would be much more convenient for you to pull it down rather than to pull it up. So it's it serves both the purpose of convenient direction as well as a force multiplier. So the best way to decrease the effort is basically to connect one fixed pulley as well as one moving pulley, one after the other, and you would get this kind of basically this is where the load would be, and that is where the effort was. So when you pull it down, again, for let's say if the load is 100 Newton, the effort would be 100 divided by 2, because the effort would be the same as the movable pulley. As simple as that. So that is the answer, guys. That is it from the teaching perspective, but now we'll also have a lot of questions based on it. So this is how it would look like. So the load is attached to the axle of movable pulley and the effort is applied in the downward direction. So again, the convenience in direction, and more importantly, it is also acting as a force multiplier. So win-win situation, and that's the best thing that you can do. Now the mechanical advantage and the velocity ratio would also be the same as the single movable pulley, which is nothing but velocity ratio is 2, mechanical advantage is also 2, and the efficiency would also be 100%. As simple as that. Now, here is some of the difference between both of them, guys. I want all of you guys quickly take a screenshot of this and keep it with you so you can refer to it when you have your exams coming up, especially your midterms and all coming up really close by. So take a screenshot of this and keep it ready so that it'll be really handy when you're going through it. So here are the difference, guys. In this pulley, the axle of rotation is fixed. In this, the axle of rotation is not fixed, or it's movable. The load is attached to one end of the rope. Here, the load is attached to the pulley. Here, it is used to change the direction. Again, like convenience in direction, here it is a force multiplier. Only direction of the force is changed in this case, not the magnitude. Here the magnitude of the force is also changed. The magnitude is what is changed, as well as the direction, because again you're applying a force in the upward direction, not in the downward direction. A mechanical advantage over here is 1, so again it's convenience in direction. Here the mechanical advantage is 2, which means that it'll be a force multiplier. Simple as that. Alright guys, so let's do some questions now. I hope you guys are excited for it, because yes, there are going to be some interesting questions as well. Once again, I want all of you guys to write down whatever the answer is in the comment section below. I don't want you guys to just sit and watch the video and walk away. It's not Netflix, so please do try out the questions. It's going to be super interesting. Let me show you some of the questions, guys. Here's the first question on your screens right now. Movable pulley is used as a force multiplier, a speed multiplier, a device to change the direction of effort, or an energy multiplier. So what is the use of a movable pulley? As a force multiplier, a speed multiplier, a device to change the direction of effort, or an energy multiplier? And the answer to this question, guys, would be option number A, because it's a movable pulley, so it'll act as a force multiplier. Why? Because the mechanical advantage is 2 and the velocity ratio is also 2. As simple as that. Moving on to the second question, guys. Here we go. In a single fixed pulley, if the effort moves by a direction x downwards, by what height is the load raised upwards? In a single fixed pulley, if the distance is x, is the distance of the effort is moving downwards, and that distance is x, by what height is the load raised upwards? Is it the same distance as x? Distance is 2x, distance is x by 2, or can't say at all. Now here it is a single fixed pulley. So the answer to this question, guys, you know it. The answer is option number A, which is nothing but same distance as x. So because over here the velocity ratio is equal to 1. So whatever is the whatever is the displacement of the effort, the displacement of the load would also be the exact same. Or the distance moved by the effort will be equal to the distance moved by the load. As simple as that. Moving on to the third question, guys. Here's another question. A single fixed pulley and a movable pulley both are separately used to lift a load of 50 kgf to the same height. Compare the effort applied. Is it 1:2, 2:1, 1:4, or 4:1? It's a very simple question. It might look a little confusing, but it's actually a pretty simple question. So you know they've given you the load. So load is given as 50 kgf. Now, thing is this, guys. For the first case scenario, I'm using a single fixed pulley. All right, single fixed pulley. Now, in a single fixed pulley, you know that load is equal to the effort. So if the load is 50 kgf, effort would also be 50 kgf itself. Very simple, direct answer, no doubt about it. Moving on to the second part of the question, if you talk about a single movable pulley over here, single movable pulley. I'm sorry about my handwriting, guys. I know you have probably seen better handwritings, but yeah. So in this case, it's a force multiplier. So whatever is the effort is equal to the half of load. So load in this case is 50 divided by 2, which gives you 25. So the effort is 25 kgf, as simple as that. Now to compare both the effort, that is I'll take this as, let's say I'll take this E1, I'll take this E2. So E1 divided by E2 is equal to 50 divided by 25, which gives you 2:1 ratio. The answer to this question is option number B, which is nothing but 2:1. As simple as that. So that is the answer for this question, guys. Moving on to the fourth question. I hope you guys enjoyed this question. It's a very interesting one. Moving on to the fourth question. Here we go. Woman draws water from a well using a fixed pulley. The mass of the bucket and the water together is 6 kg. The force applied by the woman is 70 Newton. Calculate the mechanical advantage. Take G, the acceleration due to gravity, as 10 meter per second square. So is it 0.625, 0.745, 0.857, or 0.35? That is the question, guys. They've given you the mass. They've given you the effort, they've given you the acceleration due to gravity. You're supposed to find out what is the mechanical advantage. So first of all, guys, write down the given data. The mass is given 6 kg. They've given you the acceleration due to gravity as 10 kg meter per second square. Right? Sorry, kg. Okay, I've written the wrong. Sorry, one second, guys. Meter per second square. Yes. All right. Then apart from that, they've given you the effort as well. So effort is what, 70 Newton. So you're supposed to find out what is the mechanical advantage, and the formula for mechanical advantage, guys, mechanical advantage is equal to load by effort. So you're supposed to find out what is the load. They have given you what is the effort. Now it's if you look at it, basically you can find out what is the load. So to find out the load, basically, what you have to do is find out the weight. So what is the weight? Weight is nothing but, or the force applied is nothing but, or the force applied by the water and the bucket is basically the weight, which is nothing but mass into acceleration due to gravity, which is nothing but 6 into 10, which gives me 60 Newton. So what is the mechanical advantage? Mechanical advantage is equal to 60 divided by 70. 0 gets cancelled. So you'll get the answer as 0.825. So the answer to this question is, guys, option number 857. Sorry about that. So yes, so just that point value is wrong. So if you do the calculation, you'll get the answer for this question. I didn't want to do the division in front of you guys, so it's 875. So as simple as it is. 857. Yeah, you get the answer. But the right answer is option number C, which is nothing but 0.857. I didn't want to do the calculation because you guys all can easily do that. All right. So that is the answer for this question, guys. Very simple question. You just have to find out what is the weight or the force applied by the bucket. And how do you find out the force? It's nothing but the weight of the bucket. Find that out. Very simple. All right, moving on to the next question. A pulley system has a velocity ratio of 4 and an efficiency of 80%. A man can exert a force of 100 kgf. The maximum load that he can lift using the system of pulley is what? Take a G is equal to 9.8 meter per second square. Is it 2250 Newton, 3135 Newton, 4539 Newton, or 2789 Newton? So they've given you a pulley system with a velocity ratio of 4, efficiency 80%, and the effort is also given as 100 kgf. What is the maximum load that you can take by using this? And you've also given you the acceleration to gravity as 9.8 meter per second square. So right on the given data, so VR is given as 4. Efficiency is given as 80%. They've given you the effort. Effort is equal to 100 kgf. Now the thing is this, guys. 1 kgf is equal to 9.8 Newton. So 100 kgf would be what? 100 kgf is equal to 9.8 into 100. So that'll be 980 Newton. So effort is, in terms of Newton, that's 980 Newton, because 1 kgf is equal to 9.8 Newton. So I'll get this 980 Newton. So I found out the effort. I have to find out what is the load. So first thing first, guys, according to whatever is the given data, find out the mechanical advantage. Why? Because efficiency is equal to mechanical advantage by velocity ratio. I know the efficiency is 80%, so 80 divided by 100 is equal to mechanical advantage by velocity ratio is 4. So what will I get? Mechanical advantage is equal to 80 divided by 100 into 4. So 2 to 4, 2, 5, 10, 0, 0, 0 gets cancelled. So you'll get it as 8 to 16, 16 by 5, 5, 3, 15. So you'll get as 3.2. So the mechanical advantage is 3.2. So now that we found out the mechanical advantage is equal to what? Load by effort. Very simple. So substitute the values. Mechanical advantage you got as 3.2. Load you do not, so you take it as, keep it as L itself. Effort is 980 Newton. So multiply that. So load would be what? Load is equal to 3.2 into 980. Simple. As simple as that. Multiply this, you'll get the answer. So if you multiply that, you'll get the answer as 3136 Newton. So the answer to this question, guys, would be option number B, which is 3136 Newton. As simple as that. So that is it from my side, guys. Thank you for joining. This is your homework for today. Do it and let me know in the comment section below if you want your name to be there. Do it as soon as you can and put it on in the comment section below. So here's the question. Name the type of single pulley that has an ideal mechanical advantage equal to 2. So this is the question. Name the type of single pulley that has an ideal mechanical advantage equal to 2. Let me know what is the answer in the comment section below. I will be looking forward to that. Thank you for joining, guys. I hope you guys enjoyed today's session. If you did enjoy today's session, as always, do share, like, and subscribe to the channel so that you're notified, and click on the bell icon so that you're notified and you can answer the questions as soon as you can. Thank you for joining. See you all in the next one. Until the next time we meet, this is Anoop signing off for the day, guys. I'll catch you guys in the next one. Bye bye. Take care.